Okay, welcome back to Calculus 2 here. Today we're going to take another look at integration by parts. So in this case, we've got a function times another function, an exponential times a trig function. This is screaming at you, please do integration by parts here. Now, what I usually like to do is we have to say let u equals, take whichever one is an easier derivative, and then we'll pick the other one for the integral. So we'll say let u is equal to e to the ax. Now, unfortunately, this this u is never going to go away, right? So I take the derivative as many times as I take this derivative, it's never going away. This is a e to the ax. Now, unfortunately, with the cosine is equal to, or the sine is equal to, dv is equal to sine of bx dx. Now we integrate this piece. This is also never going to go away. It's going to flip-flop between sines and cosines forever and ever and ever. So nothing is going down. Okay, so let me show you what happens with this. So v is going to be negative 1 over b cosine of bx. If you take this derivative, you're going to get back to this piece right here. Okay, now I usually do a swish and flick here in order to do my integration by parts. So I just draw my box and it's a diagonal and then flash back over. So this is going to be the integral of e to the ax sine of bx dx equals 2. And here we have negative 1 over b e to the ax cosine bx minus a negative. So we're going to say minus a negative integral of a over b, that's this a and this over b, e to the ax cosine bx. And I find myself in a very similar situation that we dealt with before. It's like instead of sine, I've changed it to cosine. Oh joy, that may not have done anything for me. It is not unusual in integration by parts that you will have to do integration by parts more than one time. Okay, it's a thing that happens. So I'm going to have to do this again on this piece in here. Okay, so we have integral of e to the ax sine of bx dx is equal to negative 1 over b e to the ax cosine bx plus, I'm going to go ahead and pull this a over b out for a moment here. So I'm just going to say it's a over b, and here we have the integral e to the ax cosine bx dx. All right. Now we are again going to say let u equals. Now, most of the time I don't like to reuse a lot of letters. This is a special case, and I know where this is going. So because I have to do the integration by parts multiple times, I'm going to use the same letters. Okay, so u is equal to e to the ax. Du is again equal to a e to the ax. Don't mix and match them. Like when you pick your u's, what your derivative, take your derivative of, pretty much you're going to ride that the whole way down. Whatever you pick for your dv, again, you're going to ride that the whole way down. You can say, you know what, this isn't working, and swap them, but don't like mix and match and do it somewhere in the middle. That's not going to help. But your dv is equal to, let's go with cosine of bx dx, and we're taking the integral of this thing. So let's see, that's going to be, we need 1 over b sine of bx. Again, if I take this derivative, I take 1 over b sine bx and take the derivative, I'm going to go back to cosine bx dx. Okay. And again, we're going to do our little swish and flick here. Okay, so again, I'm just going to write down what I have up above because I don't want to lose it. We have integral of e to the ax sine of bx is equal to negative 1 over b e to the ax cosine of bx plus a over b. And now I'm integrating this piece right here. And that's going to be 1 over b e to the ax sine bx, right? That's this piece right here. Minus the integral of, we're going to say a over b, that's this a, that's this over b, e to the ax sine bx, right? And that's what we've got next. Now, before we go a little bit further, I want us to notice something. What I want us to notice is we have an integral of e to the ax sine bx sitting here. Okay, we've got this piece right here. We have an integral of e to the ax sine bx times a constant, times two constants, sitting over here. these are the same integral, minus a little bit of the constants. We have to multiply by a constant, but they're the same thing. So here's what we're going to do is we're going to say we have the integral of e to the ax sine of bx. Actually, you know what? I'm getting tired of writing that. We're going to call that I. Okay, capital, not this I. Okay, we want to call it this I. So we have I equals negative 1 over b e to the ax cosine bx plus, I'm going to factor this a over b here. So we have a over b squared, like multiplying it here, e to the ax sine bx minus a over b, a squared over b squared, right? Because these are going to combine together. So we have a squared over b squared integral e to the ax sine bx. Oh, but I called this something. I called this I. So we're not going to call it this. We're going to call it I. Okay, so let me just go ahead and summarize what's going on here. We have I equals negative 1 over b e to the ax cosine of bx plus a over b squared e to the ax sine bx minus a squared over b squared I. I'm going to wrangle this thing and I'm going to throw this whole piece over to the other side of my equal signs here, because this is an equal sign because we have an equation. I can add things to both sides. You can't square things, but you can add things to both sides. So here we have an a squared over b squared I plus I is equal to negative 1 over b e to the ax cosine bx plus a over b squared e to the ax sine of bx. It's a mess. From here, I'm going to factor out this I. So we could say this is I times a squared over b squared plus 1. Okay, equals negative 1 over b e to the ax cosine bx plus a over b squared e to the ax sine bx. And then what we're going to do is we're just going to divide by this piece right here. I'm going to clean this up just a little bit. We're going to say this is going to be b squared over b squared. So we have a squared plus b squared all over b squared. These are all constants. Times I is equal to negative 1 over b e to the ax cosine bx plus a over b squared e to the ax sine bx. And what's going to happen is I'm going to multiply everybody on this equation by b squared over a squared plus b squared. That's going to knock this piece out over here. We're just going to end up with I, that was our integral, remember, equals. Well, the b's are going to cancel, so we're going to have negative 1 over b a squared plus b squared, okay, e to the ax cosine bx, plus, and again, the b squareds are going to cancel, so we have a over a squared plus b squared, e to the ax sine bx. Okay, and then that's where we are with this thing. That's how this integral solves out. I do believe we have a plus c in here just to make sure that we have this, but we have. Actually, no, the plus c is canceled because there's a plus c on this side, there's a plus c on that side. So we're okay. Okay, so the important part about this particular integral is that we replace the integral with the I so that we can push it onto the other side and then cancel it. Okay, so normally I don't care if you guys use the DI method that so many YouTubers like to show you, and it's a good method. There's times where I would say use this. Okay, if I had to do like a x to the fifth e to the negative x, which does happen, clearly it's integration by parts. Polynomial times exponential, it screams at you integration by parts. But every time we do this, we're going to have the x is going to go down by 1, and then we're going to have, oh, now we have to integrate x to the fourth e to the negative x. Now x to the third e to the negative x squared e. We have to do this a lot. So we apply integration by parts multiple times. I would use the DI method for this kind of a problem because it's going to be faster, it's going to be shorter, and there's going to be less to worry about. However, when it gets to be more complicated, I would not use the DI method. In this case, you can't really use the DI method because you can't see what's going on, and you have to realize that that first integral maps over to itself, and you really add it and then divide, and then you deal with it that way. Okay, so these are pretty common in calculus too, and it's like it's a rite of passage for you to see these and expect one of these on an exam. It's just one of those things where like that's going to happen to you. Okay, so what I'm going to do is, how about we try another one? Okay, this one looks a little tamer. Okay, so let's say, what if we have the integral of sine of the natural log of x dx? Okay, so in this case, we don't look, it doesn't look like we have two functions that are multiplied to each other. We have like a composition of functions here, but we still have it multiplied together because there's dx is still multiplied. So usually I was like, well, I can't integrate that. Like, well, what else am I going to do? So we'll try integration by parts. Let u equals sine of the natural log of x. I could take this in. I could take this derivative. I took calculus 1. We could do this. So du, take the derivative of cosine, we get sine. Remember our chain rule. So it's cosine of, it's not that. It's eraser. Come here. So it's cosine of the thing inside. So it's cosine of ln of x times the chain. I take the derivative of natural log of x, which is 1 over x. Now, my dv, remember, this all has to be accounted for and used all of this up. What's left? Dx is left. So dv is equal to dx. Therefore, v is equal to x. So now when I go ahead and multiply this together, I have my flick and swish here. Okay, swish and flick. So we have our uv. So we have x sine ln of x minus the integral of x over x cosine of ln of x. So cancel. And then again, at the same time, you're stuck with what's left here. So now we are left with integrating cosine natural log of x. And again, we started with sine natural log of x. Now we have cosine natural log of x. Yay, we're getting places. Not really. But we might have to apply it again. So let's go ahead and try it again. So we have our first integral. This was sine of our natural log of x is equal to x sine ln of x minus, and now we have to figure out this integral right here. So let's go ahead and do that. So we're going to say minus. Now let's try to integrate. We're going to say u is equal to cosine of the natural log of x, because that's otherwise I got nothing else to do. Du, all right, we're going to go ahead and deal with it that way. So derivative of cosine is negative sine natural log of x times its chain rule, minus 1x. And then we're going to say what's left. Well, dv must be equal to the thing that's left. That's dx. V is equal to x. So we've got cosine of natural log of x. There's an x here. There's an x out in front here. Minus a negative, so minus a plus integral of sine natural log of x. And then we have x over x times 1. Okay. Let's go ahead and factor through some negative signs here so we can see what happens here. So we have sine of the natural log of x is equal to x sine ln of x minus x cosine ln of x. Distributing this negative sign over here is minus integral of sine ln of x dx. And like, wait a minute, I've seen this before. This integral of sine ln of x dx, that's what we were asked at the beginning. And here it sits. So what we're going to do is we're going to add it to both sides. So we have 2 integral sine of ln of x dx equals x sine ln of x minus x cosine ln of x, divide by 2, and we end up with sine ln of x, the x integral is equal to 1/2 x, let's say x over 2. Get rid of that. Sine of ln of x minus cosine of ln of x. Right? And that's how you do a problem like that. You have to remember, like, it's circular. So just be careful when you have these. There's a lot of moving parts. Just trying to remember like what has to happen with this thing. Okay, I wanted to show you a couple of those because these are really important. And you will see one of these on your exams. It's always Like again, it's a rite of passage. Everybody who takes Calculus 2 gets tormented by one of these as a nightmare multiple times. It's just part of the course. It's a rite of passage. Everybody said Calculus 2. You're going to say, did you do one? Yeah, they all did one of those. You will join the club. Okay. Thank you very much for watching the video, and I'll see you in the next one. Take care.